All right, question number two. Question number two. Now in this one, class, I gave you a little help here, but you won't have this help on the test. So when you look at this, you see that, look at our previous equation, our A value right here was 1. So we didn't have to actually change it to anything. We just left it the way it was. If we think about the quilt story, there's one order being placed right here. On this one, question number two, there's actually two orders being placed. So because of that, you take a look, we're going to remove a GCF, but we don't need to remove the GCF from the last term because we're not dealing with that one. We're going to kick that down the road and we'll deal with that later. So let's go ahead and do this. I'll put my area model here. Put that down a little bit if I can. Should have had these all pre-drawn, but didn't think about it at the time. All right. So here's what we'll do now. Because we're completing the square, we're going to take this 4, this C value, and we're going to move it out of the equation, and we'll deal with it later. So now for the first two terms, now we're going to take out our GCF. And the greatest common factor between 2 and 12 is actually 2. So we're going to remove that from our first two terms. So 2 times x squared is 2x squared. 2 times negative 6x gets us to negative 12x. And now we're going to figure out what number do we need to add to that in order to create a perfect square. Now on our diagram, one of the things we showed is, so we don't forget this 2, we're going to actually say, hey, we're actually dealing with 2 perfect squares here, not 1. Oops. So I'll put that in parentheses and I'll put a 2 right out in front here. And that reminds me, class, that when I actually add the number into this lower right-hand corner to create a perfect square, I'm actually adding that twice. I'm adding that to both of these orders, these quilt orders. So that means I have to subtract them twice. There we go. Let's go ahead and complete the square. I've got x squared here. Notice I don't deal with the 2 anymore. It's now been factored out. X squared is going to go here. 6x, negative 6x, we divide it by 2, so negative 3x and negative 3x. That means I know my side lengths already. My side lengths are going to be, this is x times x is x squared, and x times negative 3 is negative 3x. And again, x times negative 3 is negative 3x. Class, this proves this is a perfect square because the length and the width are identical. But what number needs to be added here in order to complete this square? And that number is the area of this lower right-hand corner, which is negative 3 times negative 3, which is 9. So we're going to add 9 to make our perfect square. However, we also realize there's 2 of these, so when we subtract that 9, in order to put our equation back the way it started, we have to subtract 2 9s. All right, let's go ahead and write our vertex form. I'll go ahead and just start with f of x, get that out of the way. Equals, we've got 2, and then in parentheses here, x squared minus 6x plus 9. Is the area inside of our area model. That's exactly the same area as if we multiply the length and width together. So I've got x minus 3 squared. And now over here on our leftovers, we had 4, and now we're going to subtract 9 times 2, which is 18. And that gives us negative 14, and that means our final equation, we're subtracting 14. If you think about this again, vertex form, A is 2, H is positive 3, and our K value is negative 14. There is the square completed for question number 2.